Question 2. Find the minimum of g of t cubed minus 4t plus 7 on the interval -1 to 2. So this g of t is a continuous function on a closed interval. It is guaranteed that this function has a minimum. So now our job is to find the critical point. So first we find the critical point. We take the derivative of g, and we have 3t squared minus 4. And clearly this function is defined everywhere, so the critical point only happens when the derivative is equal to 0. Solving for t, we have t squared equals, so 3t squared equals 4, t squared equals 4/3, so then we have the value of t, which is plus minus square root of 4/3. And we can check that both of this number, the positive and the negative of square root of 4/3, are both inside the interval -1 until 2. So now our job is to compare the value of f at the endpoints and at the critical numbers. So compare f of square root and then f of negative square root 4/3, and at the endpoints f of -1 and f of 2. Okay, now we evaluate f at square root of 4/3. So we use Google to calculate f of that number. So g of t is equal to t cubed minus 4t plus 7, and we plug in square root of 4/3 here, as you can see. And the answer is 3.92. So let me put it here. So 3.920708. Okay, we round up to 4 decimal. Okay, and then we need also to evaluate f at negative square root of 4/3, so we just put negative sign here. And then also over here. And we get 10.07. Oh, 792. Okay, now we need to evaluate at -1, so we can replace all of this by -1, and then well, actually it is not necessary because that's just a simple calculation, which is 10. and f of 2. Okay, this is also simple, you can compute by your own. And we have 7. So the minimum value happen when x equals square root of 4/3. So this is the minimum.